Before we begin our study on Unit 2, I just wanted to do a brief overview of what Unit 1 was covering. We just finished up rational number understanding. And what we focused on in that review of 6th grade standards were how to convert fractions, decimals, and percents, ordering those rational numbers, so that was our human number line, squares and square roots with the Cheez-It squares, and then of course our order of operations, where we had good debate over making sure we do multiplication and division from left to right, and same with addition and subtraction. Unit 2 that we're going to start with this video is talking about rational number operations. So we know that a rational number is any number that can be written as a ratio, and a ratio is a comparison of two quantities. So that is typically found in the form of a fraction, a decimal, or a percent. So with rational number operations, we're talking about adding, subtracting, multiplying, dividing with fractions, decimals, percents, and integers. Go ahead and get your notes out for Unit 2, Lesson 1, should be the front page of your notes. And today's objective is to learn how to compare and order integers and to determine the absolute value. Some of these vocabulary words may be new, so make sure that you get out a highlighter or a pen as we go through these definitions to make sure you understand some of the important information. An integer is a set of whole numbers and their opposites. So if you'll notice, I gave you examples of -3, -2, -1, 0, 1, 2, and 3. So we're looking for positives and negatives, whole numbers only for integers. Additive inverse. Additive inverse means that a number that is the same distance from 0 on a number line as the original number, but on the other side of 0. It's also called its opposite. An example of this would be -3 and +3 are both 3 spaces away from 0 on the number line, and they are called additive inverses. They're really important, additive inverses. What happens when you add those two together, -3 and 3, combine to be 0. They're additive inverses because when you add them, additive, they undo each other, which is the inverse. Opposite. Opposite's another word for additive inverse. Those two are the same vocabulary word, and just same definition, just two different words to describe the same thing. Opposites are two numbers that are called opposites when they are the same distance from 0. Absolute value. This is an important concept. Absolute value is the distance from 0 to the number on a number line. Since distance can never be negative, absolute values are never negative. They're always positive or 0. So absolute value is absolutely always positive. When we use the symbols, the long lines around a number to represent the absolute value. So here the absolute value of -2 is +2 because the absolute value is absolutely always positive. Example 1 is asking us to graph the integer -5 and its opposite on a number line. We have a number line here, and we're going to go ahead and pick a spot for 0. And let's label a couple of the numbers to the right and left. Numbers to the right of 0 are positive. Numbers to the left are negatives. Pardon my stylus. I'm trying as hard as I can. All right. -5 would be 1, 2, 3, 4, 5 spaces to the left of 0, and its opposite would be 5 spaces to the right, or +5. So if we're comparing from 0, -5 is 5 spaces to the left And positive 5 is 5 spaces to the right. Remember to count the spaces. So 1 space, 2 space, 3 space, 4 space, 5 space. Don't count the lines or you'll get something different. The moral of this story here is that opposites have opposite signs. If you have a positive 5, the opposite is going to be a negative 5. If you have a negative 3, the opposite is going to be a positive 3. Example 2 is asking us to graph the integers on a number line and then compare them. When we compare them, we want to use the less than or the greater than sign. The two integers I want to compare are negative 9 and negative 18. I'm going to go ahead and get started labeling my number line, and since I can't get tiny numbers with my stylus, I'm going to label every 5th line. So negative 1, negative 2, negative 3, negative 4, negative 5, 6, negative 7, negative 8, negative 9, negative 10, 11, 12, 13, 14, negative 15. Alright, from here I can go ahead and graph my negative 9. That would be right here. And negative 18 would be all the way over here. The smaller number is going to be the number that is the farthest away from 0. Since 18 is to the farthest spot from 0, negative 18 is your smallest number, because when we read left to right, we're reading least to greatest. So negative 18 is smaller, even though if you think about just the number 18, you'd think, hey, that's got to be bigger. It's not, because it's a negative number and it's farther from 0. It's like thinking about temperature. I know negative 9 degrees isn't too warm itself, but negative 18 is even colder. Alright, so our hungry alligator mouth is going to face towards the negative 9, so negative 9 is greater than negative 18. Example 3 is asking us to use a number line to order the following integers from least to greatest. We have 8, negative 2, 7, 1, and negative 8. Let's start by numbering our number line. And I'm going to go ahead and skip every 5 spaces. This would be positive 5. That would be positive 10. That would be negative 5 and negative 10. Let's graph these numbers. 8 is going to be 8 spaces to the right of 0. Should be right there. Negative 2 is 2 places to the left of 0. 7. And then 1 should be right there. And then negative 8. Remember, when we're reading a number line, reading left to right reads us least to greatest. So we can kind of read those dots off as we go from left to right. So the first dot we hit was negative 8, and then negative 2, 1, 7, and 8. Our integers are now ordered from least to greatest. Example 4 is asking us to use a number line to find the absolute value. Remember, the absolute value is the distance from 0 to a number on a number line. Since we're talking about distance, you are always going to get a positive value. You're never going to say, I traveled negative 13 miles. That just doesn't make sense. You say, I traveled negative 13 miles, or I traveled 13 miles left, or 13 miles right, or north or south. You don't use a negative sign. Distance is always positive. So absolute value is absolutely, absolutely always positive. Let's go ahead and find the absolute value of negative 7. Remember, we use those straight up and down lines to represent absolute value. And I'm going to go ahead and graph this on my number line. I'm going to think about 0, and then I'm going to go to the left 7 spaces. Negative 7 would show up right here on the number line. To count the absolute value, I want to talk about how many spaces it's away from 0. So 1 space, 2 space, 3 space, 4 space, 5 spaces, 6 spaces, 7 spaces. So the absolute value of negative 7 is positive 7. You can get in the habit of looking at an integer and saying, hey, the absolute value of negative 8 is positive 8. In other words, you're just dropping that negative sign. But be careful, because the absolute value of 4 isn't negative 4, because remember, we're talking about distance. The absolute value of positive 4 is still a positive 4, because absolute value is absolutely, absolutely always positive. And if I graphed 4 on this number line, and I counted the spaces from 0, it would be 1 space, 2 space, 3 space, 4 spaces. There's no such thing as a negative space. There's always positive spaces. So my absolute value of 4 is 4. Okay, so this is an important concept over ordering integers from least to greatest, making sure that we're aware of what an integer is and its opposite, or its additive inverse, and then also introducing the concept of absolute value as the distance from 0 to another number on the number line.